Let me know when you can see my screen. Yeah, okay. So today I'm going to talk about mobile security. So first of all, I'm not an expert in security or anything. Also, not much of a English speaker. So sometimes I'll make some mistakes. So sorry for that. Um, Today I'm going to share with you some of my studies in this area. Since last year, here in Brazil, we have a very important law about information security and digital products. Security in digital products and data privacy and etc. So since last year, I started to study about this topic, and I've read a lot of books and a lot of material about the subject, and then I decided to share with you guys today. Okay, so some things I won't know. Because I'm not an expert, but I know quite a bit. And also, I'm going to align expectations with you. Uh, we won't have anything advanced. Um, we won't have code. There won't be live coding or anything. We will learn some concepts and some fundamentals, and then we'll have a little hands-on, but not with code. Okay, we will do like a kind of a reverse engineering thing with an app that I created to bring here today. So this way we could like simulate what would happen with a real app if we don't get serious about security. Okay. So I'm Anna Coimbra. Nice to meet you all. Now I'm head of engineering at Kobe. Kobe is a software house here in Brazil. We develop a lot of products, mostly mobile apps, but we also have a lot of web apps as well. And lately, we've been working on a lot of e-commerce app. When we can shop online stuff, all kinds of stuff. And I have some colleagues here. Hello to them. Since we've started to work with big companies and those e-commerces that need to be PCI compliant and have to have big security issues and concerns. So we started to take security very serious here. I'm also community manager at Android's DevBR, is an Android community here in Brazil, the biggest one in Latin America. And we have a Slack channel, we have a website, we have a Medium, a very busy, very full of posts Medium. But everything is in Portuguese, so if you don't speak Portuguese, I won't ask you to join us. But if you do speak Portuguese, please join us. It's a very good community. I also love cats. I love sitcoms like Friends, How I Met Your Mother, and the new ones from Netflix. And I also love hero movies from Marvel, from DC, and etc. I sign every streaming platform because I love them. Okay, let's start, right? First things first. Um, if we are going to talk about software security, right? It doesn't matter if this is mobile, if it is web, if it is desktop or whatever. We need to turn to who mastered the subject, right? So I went to OWASP. It's a global foundation of software security. I forgot right now the meaning of every word here, but uh, in in uh, in general, they are a foundation, a global foundation for software security. Okay, and everything you want to know about this software security, data privacy, and all this stuff, they have it there. They have a project, mostly open sourced, and they have a lot of tools as well, so you can test your mobile apps, your web apps, whatever. And they also have a lot of ebooks and a lot of content that you can learn with. Okay, so first of all, we have our top 10 mobile risks. So the first one, this is from OWASP, okay? They made the research, and from this research, they found out the big risks from that a mobile app can have. So the first one is improper platform usage. This covers the misuse of every platform. So, for example, in iOS, we have the keychain, also in Android, but we have Touch ID, biometric systems to perform security. And if we don't use it right, we are going to that first risk. We have to use it correctly. So, for example, the Android intents, the platform permissions, if we don't correctly ask for permissions, and the least permissions that we could ask, we are not using the platform properly. The second one is insecure data storage. So threat agents do like stole or lost their. For example, if someone is got their mobile phone stolen or lost, someone could invade, and get some data, some important info from that. So we have to secure our data, whatever it is. If it is the database like Sqlite, if it is core data from iOS, if it is a file, an important file, if it is shared preference, whatever, we have to secure it, especially if we are dealing with sensitive data. Also, we have insecure communication. So everything we do in an app is not done like local. We have to communicate with the internet. We have our servers, our backend services. So we have to make this connection secure. We can't afford to have, for example, some people intercepting, doing like a man-in-the-middle attack with this communication. Okay, next one is insecure authentication. So we have differences here. We have insecure authentication and we have insecure authorization. They are mostly the same, but authentication, we authenticate an user, so I can guarantee that that user is that one that is saying who it is. I don't know if that's clear, but we can assure that, okay, myself is myself correctly and not someone passing through myself. Is that okay for you? Okay. And authorization that we have here as well is to authorize the correct people with the correct access, you know. So if I am not, I don't have the privilege to access some content, some data, some resources, I can't have this access. So this is the difference of authorization and authentication, okay? Okay, I passed this one, but let's go back to insufficient cryptography. So anyone with physical access to the data, to the device, can, you know, decrypt the data, these resources, and you know, getting from there. So whenever we use, for example, poor cipher algorithms, we are going through this problem. Okay. So client code quality. This client code client is whenever we don't use the best practices in development, you know, in coding. So this usually is not a secure issue per se, but it leads to secure problems, you know. So for example, if we don't implement very well some structures from the platform, from, you know, code best practices, we could lead to a high risk, for example, jailbreak or rooted attacks. So this is a big problem. Also, we have code tampering, when someone can perform a code modification through a malicious form. You know, you can, for example, during reverse engineering, you can change the code from your app, because, you know, you could reverse it and then rebuild it and then reinstall it, and then, you know, we could do whatever we want to do. For example, get back to one of the others risks, like insufficient cryptography, or insecure communication, or authentication, you know, or even data storage. Okay. Next, we have reverse engineering. I think you all know a little bit about it. Is when we can download the app, you know, the resources from app, and could analyze the code, could see whatever is going on there with our app code, you know. This is a little bit what we are going to do today, reverse engineering with a little inspection. So the last one is extraneous functionality. I don't know if I pronounced it right, but typically an attacker seeks to understand extraneous functionality. So he or she would discover a hidden functionality in backend systems, in other resources related to the app. Okay, so this last one usually doesn't even involve the end users. Someone could like do it, you know, by hacking the source code or by hacking the server, you know. Okay. Still going with OWASP, we have two main projects that we are going to work here today, and the ones those was the ones that I studied the most. So we have first the mobile security testing guide. This is the main one. It's like an ebook that has a guide to find security vulnerabilities on both platforms, okay, Android and iOS, including hybrid apps. If you use Flutter or React Native or Xamarin, they also have something for that. This is a very, very good ebook to read. I read it in the beginning of the year. Has a lot of details, a lot of tools, to use. I took parts of it for here today. So there's a lot of things, but we couldn't do it like in one meetup. So you can search for it. In the end, I'll have the link so you can open it. It's in GitHub. Okay, the second one is mobile security verification standard. So this verification standard is also an ebook, but it established baseline securities requirements so you can use in your mobile apps. And it's useful in many scenarios. For example, you want to guarantee for your client that you have at least the minimum security requirements, the basic requirements for security. So they have a standard, like a checklist. So my app does that, does not does that, and this is a very good like starting point, so you can know whatever you are in security topics in your app. So here we have the levels of the MOSVs, the mobile application security verification standards. The first level is the standard one, the level 1, L1, right? So we have the standard security. This is applied for every mobile app, doesn't matter what about it is. If it is a basic app, if you release it to the public, you have to have at least level 1 security. Because it concerns the very basic of security best practices. And it goes with code quality, handling sensitive data, interaction with the mobile environment. The next one is level 2, is defense in depth. It concerns advanced security controls, and goes beyond the standards, right? So it's usually for apps that handle highly sensitive data. For example, financial apps, medical apps that have very sensitive data about health issues, or governmental apps, or whatever app that have a very, very sensitive data, that handle very, very sensitive data. Okay, security is done by design. Okay, and the last one is the resiliency level. So we have resiliency against reverse engineering and tampering. This is a very basic level, but you can't be, for example, this R level without the other two. I'll tell you about this later. But if you are resilient, the name said itself. you don't permit to have tampering. We talked about tampering, modding. No one can modify your code or could see your code, or okay, maybe see but not understand your code, to understand whatever you did with your coding. And it's applicable to apps that handle also highly sensitive data or needs to protect intellectual property. For example, if we have a property app, it's usually good to have this R level here. Okay, so which level to choose, right? It really depends on the contract you have. If you are working with a software house, or as a freelancer, if you have a client, it depends on the contract you have with this client, or it depends with the business model or the requirements for this project. You have to analyze it very well, and it's a basic risks versus cost situation. The higher the level, the higher the costs, but you usually do that if your risks are too high to lose, if you don't spend much money with security. Okay, so here's like a matrix. So if you have lower budget, you usually have the minimum, so the L1, the level 1 security. If you have a little bit more budget, but you can still get less risk, you can add the reverse. You can be resilient to reverse engineering and tampering. But if you have a higher risk, so if your app is very important, you handle very sensitive data or very important stuff that cannot be breached, or cannot you can't handle to suffer an attack, you have to go to level 2, and then level 2 plus the resilient one. Okay, so this is basically it. You can choose based on the project. It's not this is not like something that it's very very defined. You can search a little bit and study a little bit about the project, and then decide whatever the level that it should have. Okay, so now we have some key areas in mobile security. There's something very interesting about mobile security, because they have a smaller attack surface, because the operational system itself, like Android and mostly iOS, they themselves just perform a very secure layer for us. So mostly we have to secure injection or data privacy, data protection, and the network connection. Okay, so these are the key areas. The first one is local storage. So as we said, we have to use proper use of their operating system APIs, so we can store local data safely and especially sensitive data, okay? And then don't have to, we don't have this vulnerability, okay? And something that is very important here also is the inter-process communication, you know, when we call a different coordinator, or if we call a different intent. So we have to be careful when we pass information through that, okay? The next one, communication with trusted endpoints. So we have to have a secure network communication. So we don't have, for example, man-in-the-middle attacks. We don't have problems with public Wi-Fi's networks. It's usually not good. So we have to prepare our mobile apps to get secure for that. Always use the TLS protocol for these settings for, you know, network communications. Authentication and authorization. So sessions are handled in the backend or the server. The mobile app locally doesn't share anything about sessions, you know, only the token, and the token has to be encrypted, preferred in a good crypto algorithm, not a very weak one. So the device doesn't have, you know, for example, the email and the password, and then it performed the login. It just have the token, that the token is sent to the server, and then the server do the rest, you know, it handles the rest. Okay, the next one is interaction with the mobile platforms. So we have to use properly the hardware and resources from Android and iOS. Again, things like permissions done well, and opening these resources only when it's necessary, and asking for permissions when necessary. Also, again, the IPC APIs, the inter-process communication APIs, doing properly. The next one, code quality and exploit mitigation. So we have to follow code best practices as always. This is the minimum. I know that sometimes we can't because whatever the reason, but this is the least we could do, you know, to prevent some issues. We have to perform a very good memory management. If we create like a memory leak, or a stack overflow, not a stack overflow, like a buffer overflow, it could provoke some attacks from malicious subjects, okay? And also protect from injections, SQL injections, data injection, network injection, okay? And last but not least, anti-tampering and anti-reversing. So basically, code obfuscation and shrinking, so no one can read and understand and change our code. Okay, let me see if we have some questions already. When we root, okay, ma'am, when we root any mobile devices, does the security of the devices decreases? Because once we get into the recovery mode, we can even change the entire OS of the system. Please share some views with us. Okay, so when we root some devices, I don't think we lost we lost security in the device. Mostly we lost. Okay, let me rephrase it. I think we lost a little bit of security because that layer that the OS gives us is a little bit less secure. Okay. But we also can do it ourselves. So we can configure security in rooted devices. And also this, all of this stuff that we are going to do today has to be done in a rooted device, because otherwise it won't, the reverse engineering won't be able to be happen. Okay. But yeah, when we changed the entire OS, we could lost security in that device, especially if we downgrade that. Is that okay? Okay. So let's go to the hands-on, right? First of all, we're gonna need some tools. I put it at the QR code, so if you want to download it now, you can. But I don't know if you all have time for that. But I will share with you all the slides later, okay? So you can do it later if you want with the code also. So the first thing we are going to do is start an emulator. I just started here to make it quicker. So here we can list the emulators. I'm sorry, you're not seeing. We can list the emulators, and for example, the one that we are going to use is that second one, the Nexus. And to start it, just emulator at and the name of the emulator, just like it is here. Okay, so it starts this emulator here. I have to start it as root. Remember, I have to have a rooted device to perform this reverse engineering. And just so you know, if you didn't know, every emulator is a rooted device. So the first thing we're going to do, the root. So now my device is rooted, so I can do whatever I want with it. And mess with the files, download, send files to that, Okay. We have one question. Do you know tools or methods to prevent my app to be installed by a rooted device? Yeah, I'll share with you later. Yeah, I do. Okay. So my device is now rooted. First of all, I'm going to just so you know, I have already installed two apps. The Crack Me app, this is the one that we are going to crack and perform the reverse engineering. And the Don't Crack Me app is the one that I perform the security issues. I coded the solutions for that. Also, I'm doing that in Android because it is the platform that I know most. I don't own an iPhone, and I have a very poor knowledge in iOS development. And also because it's easier. it is not easy to have a jailbroken iOS device, and Android is just to launch an emulator. Okay, so now I have two apps. I'm going to download this one, this APK here from this one, because we are going to reverse engineering that. Okay, but first of all, let's see what it does. Okay, this is an app to randomly create facts from cats or dogs. Okay, so first I'm going to say I'm a cat person because I have two cats, right? And then when I click this button, it generates not it actually I think we have a problem. Okay, the Heroku server was down. Okay, so now we have a random cat fact here, and then I can bookmark it. Okay, now it's saved here. I can generate a new fact. Okay, and the new one. Okay, this one is the same as the thing is I only have registered like 4 facts, so they will repeat a lot. So this is the app. Okay, so we have here maybe web services, web server, a backend server that I call an endpoint here. And then I could have maybe shared preferences. And, do I have a local storage, for example, for a database, for a Sqlite database? I don't know. I don't know if I'm not sure if I have shared preferences. Who knows? Okay, I'm saying that because normally, if you are going to perform this pen testing, right? You don't always know what it has. For example, I know that this has a SQLite database and it has shared preferences. But you can run the app and see whatever it does go through all screens. And then, okay, it generates a new fact, maybe from a web server, maybe from local server, I don't know. And I can bookmark the facts here, and it goes there. Maybe it saves something in the shared preferences. Okay, so we analyze this in a big picture, and then we can download the APK and the other resources so we can perform our reverse engineering. Let me just do something here. Okay, so first of all, we're going to list all running apps, actually not all installed apps from third parties. Okay, so the command is adb shell pm list packages -3 -f. This way we can list every installed app in the device that are not from Google. Okay, and we also have the exact for the APK here. Okay, this is the correct one. No, this is the secured one. This is the correct. Okay, now I'm going to download it. So this one. Can you all see the everything? The terminal, is the size of the text good? Okay. ADB, boom. So now I have the path of the APK here. I can download it. I will download it to this folder right here. Okay, great. Downloaded. So now I have my APK here. These two here are the ones that are already installed. Okay, but let's pretend we install it from the Google Play. Okay. Okay. Next step, we decode the APK. So we have to run this command right here. We do GDG. This is a tool that you can install from Homebrew or some from the source code or from Package Manager. Minus E minus F. Going to put it out main base APK. This is a tool that gets this APK and decode it to Java code. You know, it has some errors, but I think we can open it. There is another tool that does the same. Let me just open that code out. That does just the same, but the Java code is encoded. So this is why I'm using this JADEX. But we can use APK2 as well. And this is the command, dbase APK, okay? And then it does the same. It creates a lot of files, decoded files. So let's see what we have here. Okay, we have the manifest. We have everything from the manifest. I know the theme. I know the activity. I know the services that it uses. The icon. I know if it allows backup, everything. I could, for example, using APK2, get here actually, but I could okay, APK2 just what it should be. But APK2, remember when we talked about tampering? I could, for example, change here. I want now to have a different name here. So, or a different icon or whatever I want to change in their code in here. And then I can rebuild it into another APK and then reinstall it in the device. So this is very not good, right? So, for example, we could install a network network config. Remember the network config? If you're a developer, I think you know what I'm talking about. And then you could intercept like any network session in here. Okay, so we have these two. This one is from JDX and this one is from APK2. We have some differences here. For example, here we have Java and then the Java code here. those are the libraries. I'm going to go to my source code, and then we have some things coded, but mostly here. Some callbacks. All my I did it in Kotlin, okay, so it's compiled in Java. Okay, I have some things there. Default path. I have here. Okay, I have very basically all of my code here. Everything is here. I could change something here and rebuild it. Let's see here. The original. Okay, see what I told about it gets encoded. So everything is like encoded. We have some properties. We have a Smiley code. The Smiley is from the framework, the Android framework. But okay, I have the BR here, the build config.smiley. Okay, I found something here. Okay, we have our token. So I can get the token right here. This is not right, right? I shouldn't be able to get it here. I also have the URL from maybe Catfact. Maybe it is from my server. Okay, I have a lot of information. So this is the build config. Remember when we set a variable in the build.gradle file? It goes here. Everything is here. We could go to the strings files. Okay, strings, nothing here. Okay. We have the resources here. Maybe here in the strings we have attributes. Every attribute here. I could change any of them. I could change the Boolean. I could change some colors, maybe, to see something hidden or to hide something, I could go here and every string is here. So if I create a secret string, please don't put it in the string.xml because it's going to be here. Okay. Okay. We have the styles here. I could change the styles, any style here. This is from every library that I use and also my own app. Okay. Next step. Let's download the database, right? We saw it here that we have database. Yeah, we have a database here. Roam, right? We use Roam. We use Redofeed. We use shared preferences. So we have our own database, a Sqlite database. So let's go there. And this. Okay. ADB, pool, data. If you don't know this sequence, you know, this sequence right here, you always can go ADB shell and so remember that we are rooted in this emulator, okay? And then we can go cd data and ls and cd, you know, we have everything from our card here, from the device here. And we have cd data again. This is like a default, okay, for every app resources. We have data and then data again, and then we have the package. Okay, so cd, oh sorry, it's data and then com dot. Okay, here we have all packages from all installed apps. So cd dot, I'm going that correctly. So now we have ls. So we have cache, we have databases, and we have shared preferences. I'm going to download now databases. Remember that path here. I'm going to exit the shell and then db pool databases and adb pool shared. Oh, sorry, prefs. Okay. Now I downloaded the database files here, and I also downloaded the shared preference file here. Okay. Okay, shared preferences downloaded. So we have to check for sensitive information, right? We already checked strings, doesn't have any. Build.gradle, did we search in build.gradle? No. But we don't have anything here. Let me see here. No, not here. No, we don't have anything. Okay. So mostly we use the build config file. We have some problems, right? Not the Java one, but the Smalley one we use. We still have this access. If we configure a secure string here, we could get it right away. Not that hard to get, right? Just use APK tool. Okay. And check for sensitive information in other places. For example, database files, shared pref files, or any external files. I don't think we have any external files here, but we could search for it. Anything we could like keep working in this, keep using this app, but you know, I know we don't have it here. But we have a database file and we have shared preference file. Let's see what we have in the shared preference file. Okay, we have keys here, and we have one string, the lex, that is cat. Remember that I chose cat person? This is stored here. So okay, this is a good, there is no problem storing that because it's not sensitive. But what if I stored a sensitive information, like, you know, an user email or an user password, maybe, or any, you know, any sensitive data that could give the user some trouble? Okay, this would be right here, just in like couple of commands. I just get this information. Okay, so let's see what we have in the database file. So I'm going to open it here, and I have the Sqlite Browser. Okay, this is the browser. So, okay, I have the two items here. Okay, the two items that I bookmarked. Remember? Those two are here. Again, not a problem here because it's not a sensitive information. But what if it was? For example, I share if I stored the user ID, for example, you know, uh, the the ID of the user. In Brazil, this is forbidden right now because of this law that I talked about in the beginning. So this is a very important issue. We have to secure our database because this was easily opened in like 2 clicks here and a couple of comments here, right? So did you see how easy it is to crack an app, right? So let me see, what do you think about it? What we've done here, did you know about it? Is it a surprise for any of you? Did you know how much we could get in using those tools? Okay, this was new. Yeah, this is a basically a very basic app, but I just use the basic coding skills, you know, the basic coding stuff from Android, and not caring much about security, and not using any other tools, just the basic ones. And then we could get everything, right? So remember when we would use in a bigger app or a very important app, this is very risky. So the next one would be to intercept network requests, but I won't be able to share it with you because I'm having some issues with the certificate from Burp. But actually, we have this Burp here, and we have to configure a proxy. But I'm having some issues with the certificate from the proxy. So I don't think we could make it. Let's see. Yeah, not working. But usually when it's correct, we could see the request here with all the data that is sent, the JSON that is sending and the JSON that is returning, you know, the response and the request, everything. So I'm sorry, guys, but I really had this issue right this evening, and I couldn't fix it in time for this. But it was working like last week. Okay, but if you want, you can configure Burp Suite and then configure the certificate and download the certificate, pass it to the device and install it. The device you can configure in the settings here. It's here, security, and then is installed from SD card. I already uploaded it here, and then you just install it. Very easy. You have to set up a PIN or a security unblock way for your device, but that's it. Usually works, but now it's not working. I don't know why. I'm so sorry, guys. But if you want to test it, you can do it. You can use Burp Suite. You can use Charles proxy, you can use the OWASP proxy called Zap proxy. Let me write it down here. Charles proxy, Burp Suite, and also Zap proxy. All of them do that kind of network interception. So we can see every network connections and requests and responses from the devices. Okay. Okay. So how do we prevent all that, right? How do we prevent to read from database this easily? How do we prevent to read this code this easily, to read everything, how to prevent this stuff from happening, this attacks from happening? The bad news is there is not a bulletproof situation here that we can be 100% secure, but we can do some stuff to, to get it harder for attackers to hack our apps. Okay, the first one is secure preferences and encrypted database. So we can encrypt our shared preferences and we can encrypt our databases. But the preferred way is not to save anything in the device. So save the least data that you can in the device and save all of them in the server, not on the device. Okay. Root and jailbreak detection, root for Android and jailbreak for iOS. So prevent apps from running in rooted and jailbroken devices. Code shrink and obfuscation. This is mostly for Android. iOS is this is done by design. Every release build, as long as I know, is already obfuscated. So this way we can prevent reverse engineering in code inspections. This would be a lot harder to read the files that we read here today in here. For example, this Java code is going to be a lot harder and a lot smaller. Lots of these classes won't be present. Okay, next one, remove sensitive data from logs and files. So avoid the most that you can to log anything, any information, log the least that you need. Remove any files or anything that you don't have to use. And if you have to use any files, please use a secure encrypted algorithm and encrypt it. So remove API keys, tokens, and any other sensitive data from code or logs, because as we saw here, we could get it in a reverse engineering stuff, in a reverse engineering process. One of the most important is use secure algorithms. So when we are encrypting some data, please use preferred asymmetric algorithms. Usually keychain, when we need to get our digital or our Face ID, our Touch ID, or any other secure from the device is preferred. But don't ever use like I don't know the name in English, SHA1, or base 64, those are very poor algorithms that are very, very easily to decode. So if you encrypt with those algorithms or don't encrypt, is like the same, So use strong algorithms. And one of the most important ones as well is SSL pinning and block non-SSL traffic. So configure an SSL pinning. What it is, okay? Your server only will only communicate with you through a certificate. So we can guarantee that we don't have an attack from man in the middle, a man in the middle attack, okay? For example, if my app has a certificate to communicate with my server, only with that certificate we could communicate. If we don't have this certificate, the server won't serve, the server won't respond to anything, and my app, if doesn't get to that server with the same certificate signature, my app won't receive anything or won't send anything, okay? So we configure a certificate for SSL pinning. And also we don't allow any HTTP without the S request. So we always have to have TLS or SSL traffic, okay? So I don't know how much time do we have, but I implemented the secure version. The only thing I didn't do was the SSL pinning, because I couldn't configure a certificate from my server. But the last ones I did as well. I can. How much time do we have? Yeah, do we have time to review the secured version? Okay, so the same app, okay, just with security issues implemented. So I can save it here. I can generate new facts. Okay, cats need blah blah blah. Okay, so first of all, I already listed the APKs here. I'm going to download this one. Let me just okay. I'm going to download it to my device, to my computer. ADB pool. Okay, now I have my base APK. I'm just renaming all that I already downloaded, okay, so it doesn't get rewrite. Okay, so now I have my APK. I'm going to perform a reverse engineering out secured. So now we are going to see the difference between obfuscated code and a non-obfuscated code, okay? And also with APK. Okay, so code out secured. Let's see the difference, okay? I have libs here. Manifest the same. We have properties here. We have a jar. Let's see the Java code. The compiled Java code. Okay. I have some, some unreadable code here that I cannot identify what it is. Let's go to my package. Okay, I have fewer classes, right? I don't have these two. This the same. I don't have my whole code here, and it's like not readable, right? So it's very, very different. Let's see. I have generated. I don't have generated here. Domain. If you are familiar with Android and ProGuard and this tool, these ones that are here are the ones that we use that keep word in the ProGuard, like use it keep or keep class. Those are the ones that got here, but also not readable. At least maybe this fact here, this model, because I can read this, but most of them are obfuscated. Okay. What else? Let me run it so we don't pass much the time. Let us download the shared prefs. Correct me. Secured. Okay. The database. Secured. Okay. So shared prefs. Sorry. Code. Let's see here. This is the one not encrypted, and this is the one encrypted. So my likes and the value cat here turned out to be this one encrypted. So a little harder to read, right? You could like try a brute force here to find out this to decrypt it, but okay, a little harder to work here. And let's see the database. Secured. Okay, it asks me for the password, but I don't know the password. How could I know the password? Because I used an asymmetric algorithm, right? So it uses the device security platform. Maybe the keychain, maybe whatever. So I don't have the password here with myself, and it doesn't go. I don't have it on the code, so I don't know where it is. I could search for it, maybe. Let's see. Password. Sqlite password. Okay. No, I don't know. I don't think we have it here, but it's a little harder now, right? So not as easy as the other one was. Okay. Moving on. First of all, this is the code. If you want to download it, to play with it, this is the code for this app that I'm showing you guys. This is the link here. I don't know if I'm able to send a link, but okay. There's also a QR code as well. Let me see, we have some question and answers. Okay, to completely hide, is it possible to completely hide our password protect source code? I actually don't know. What I know is that we can obfuscate, like we did here with ProGuard. But some things we still have to have it here, so the app could work. For example, when you use keep classes in ProGuard, because I don't know, when you compile the source code, it has to be there, Okay, I'll get to you, Arthur, in your next question. First of all, the references. The first one is the ebook of Mobile Security Testing Guide. The second one is from the standard, the verification standard. The other two are from the Key Store and Keychain from Android and iOS. Those are the preferred cryptographic algorithm that we should use when storing sensitive informations. Okay. Okay, now about the tools. The first one, root beer, is a very used, a large used tool to detect rooted devices. I think for iOS they have a native library, a native API that does that. Second one, the second and the third are the TrustKit tool. They are very used for SSL pinning. The first one for Android, the second one for iOS. Okay. We have a project here at Kobe that use both of them, and also Rootbeer. Here we have jailbreak detection as well, another tool here. To encrypt the database, we used SQL Cipher. So it asks for the password here. We have to configure a password for that. And to configure a password, we use the keychain, the key store here, okay? So this we have to mix the libraries a little. And the sharing preference has a new for Android. It has a new library that we can encrypt the shared preferences just like this, right here, and it encrypts and decrypts very easily in the code. I don't know what it does in the background, but in the code is very easy to do. You can, if you want to check the code, I have a branch called main. There is the first one that we hacked, that we saw, and other branch that is called security, that has all these implementations, so we can check how it's done. Okay. Well, thank you. I don't know if I answered all the questions. Arthur, is everything okay? Still have a question? But you also work with me, so I can help you later. Yeah, you're right. Okay, guys, so any more questions? You can follow me on Instagram or Twitter or LinkedIn. I'm always there. Or send me an email if you have any, questions or any concerns or any, any feedback. I'm open to it. Okay, thank you. Thank you again for GDG Sacramento for the invitation, and sorry for my English. I'm still practicing.